Welcome to the video for 5-4A, medians and altitudes. Well, this one's just going to be about medians. We're going to talk about what happens when the medians of a triangle all intersect. They meet at a place called the centroid, and that's what this video is about, using the centroid to find some side links and some missing values. Okay. So first things first, what is a median? A median is just a type of segment inside a triangle. And you have to look at the endpoints to understand what it is. The endpoints of this one is a vertex of the triangle and a midpoint of the side opposite. What that means, any median will start at one of the vertices of the triangle. It'll go all the way across to the other side. It'll hit right at the midpoint. Now, this is not the same as a perpendicular bisector because it does not need to be a right angle that these meet at. Okay, so that is one median. If you draw in all three medians, you get an intersection point called the centroid. Okay, and the centroid has this 2/3, 1/3 relationship with some distances. So here's what I mean by that. If this is a median, I know that the centroid is breaking that median up into a piece that is 2/3 of the whole thing and a piece that is 1/3 of the whole thing. Okay. And we're going to use some math to figure out what exactly is the distance on some of those. I'm going to do a little bit of a different way than a fractional approach. But the centroid always cuts each median into in a spot where there's 2/3 of the length on one side of the median and 1/3 of the length on the other. So again, the word that we get when we run the medians into each other is called a centroid. That's the point of concurrency of the medians. This centroid is going to always be inside. You can't make the centroid pop outside of the triangle. Something notable about the centroid is that it's the center of gravity or the balancing point of a triangle. So if you had a triangle, maybe cut out on a piece of paper, you could draw the centroid by connecting all the medians. You could put your pencil under that centroid and it would balance. That's where all the weight is centered. So let me show you how you might be using the centroid to find different side lengths inside the triangle, within the triangle. Okay? So it kind of starts by looking at what they gave you. In the diagram at the right, XA equals 8. Okay? They're saying what is the length of XB. So they gave us between X and A is 8. Okay? They want what is the length of XB eventually, okay? In order to figure out the length of XB, I need to know what the length of AB is, okay, the green piece. So what I do with these is I call green, the green piece that I have up here, the short piece, okay? The piece that they gave us, the blue piece, is like your medium piece, okay? And then the red one is like the long piece, all right? They're asking us to get the long piece. What I know is that the short piece plus the medium piece will equal the long piece if I can add those up together. Okay? So what they want us to find is the long piece, which is called XB. So they want the length of XB. What they told us was that XA equals 8. That was given. I need to find the short piece, which is AB, so that I can add it to 8 so that I can get the total. Okay? What I know from the theorem before is that the medium piece is 2/3 of the entire red side. The green piece is 1/3 of the entire red side. So instead of using fractions, what I would do is look at how much bigger is the blue one than the green one. Well, if the blue one is 2/3 of the entire thing, I know that the medium piece is twice as big as the short piece. All right, so if I'm looking for the short piece, and I know that the medium piece is 8, and I'm looking for AB right now, all right, AB has to be half as big as the medium piece, since they gave us the medium piece. So I know that piece has to be 4. All right, we'll practice that again in just a second here. But I needed to find that short piece so I could add together for xb, 4 plus 8. The short piece plus the medium piece will equal the whole thing, or the long piece. So the long piece, the whole thing, is 12. Okay? We're going to look at the exact same picture and try it again with just a different measurement at the beginning. This one says in the diagram at the right, ZA equals 9. That's the piece between the centroid and the vertex. So this is the medium piece. All right? CA is the short piece. We want ZC, which again is the long piece. They want the whole thing. So what they gave us this time, again, is they started us with the medium piece. The medium piece is that ZC equals 9. Okay? We want the long piece eventually. I'm sorry, not ZC for 9, ZA, my fault. ZC is what we hope to find. What we need to figure out then is how long AC is, which is the short piece. If I can figure out what AC is, then I can add those together. All right? Well, with this one, AC is this piece right here. This is the short piece. I know the short piece is 9 divided by 2. It's half as long as the medium piece. So that's 4.5, which means I can do 4.5 plus 9, which was given to me as the medium piece. And we're going to say that ZC has a total of 13.5. Remember, this is a 2/3 and 1/3 situation, so decimals will be common. That'll happen pretty frequently. All right? So let's move on, change gears a little bit, and then we'll come back to that type of problem in a second. This one says use the figure at the right to name each segment. Okay? These can be kind of tricky. You're looking to name a median in the triangle ABC. So let's draw the triangle ABC first. Okay, that's blue right here. A median in ABC will go from the vertex across the triangle and hit a midpoint. Okay, so I would look at the endpoints here. I don't have a line coming out of B over here, so I'm not going to do anything involving B. I have 2 lines coming out of A, I have 1 line coming out of C. But if I look at the side opposite of A, so the bottom side, I don't have anything marked that would tell me I have a midpoint. Remember, medians need to go through a midpoint. If I look at this last side, I know that J is a midpoint because of the tick marks. So if I trace that across, I see that JC or CJ, either one, is a median of that triangle. Okay? If they're asking about AHC, that's this triangle right here, AHC. Now I don't have anything coming out of A. I do have one thing coming out of C, but it's not meeting at a midpoint on the red side. If I look at what's coming out of H and trace that across over to I, that is a midpoint by the markings. So either HI or IH would be a median of that triangle. All right, so you might get questions just asking about how to name the medians. Okay, all right, let's try this one then, and then we can try one more just like it here shortly. This one says P is the centroid of the triangle, so that's right here. They're going to give us the length of MP. So between a vertex and P, that's 14x plus 8y. Okay, that's our medium piece. All right, they want expressions to represent PR, which is the short piece, and they want all of it, MR, which is the long piece. Okay, so that would be the whole thing. All right, this is going to be what we were just discussing just before. What we know is that the medium piece is MP, which is 14x plus 8y. All right, if I can find the short piece, which is PR, I can add the short piece plus the medium piece to get the long piece, which is MR. Okay, so the short piece is half as long as the medium piece, or 14x plus 8y all divided by 2. So even though there's algebra in this, even though there's letters in this, it doesn't make the problem any tougher. I'm just going to use distributive property and use 1/2 times 14 to get 7x, and then 1/2 times 8 to get 4y, and that's the length of PR. So then what happens with MR, the whole thing, is I'm adding 7x plus 4y, which is the short piece, plus 14x plus 8y, which is the medium piece, to get the long piece. This is just combining like terms. 7x and 14x make 21x. 4y and 8y make 12y. Okay, so in all of our examples so far, we've gotten the middle piece first, the medium piece first. We can cut that in half to get the short piece, and then add short plus medium to get the whole thing. Okay, this time they start us with AD, which is the whole thing, so let's see how that changes things. Okay, they gave us the total, which I guess I've been making red so far. All right, they gave us all the way from A to D is the long piece, which is equal to 15x squared plus 3y. Okay, here's what you might want to do if they give you the long piece first. I know I need the short piece, which is FD, and I know I need the medium piece, which is AF. Okay, one thing that you can do is get that short piece first. Remember what we have here. We have 2/3 and 1/3. Okay, it's easier. You could definitely multiply what we have by 2/3, and you could take that times what we have and get what you want for the medium piece first if you want it. But what I know is that FD is 1/3 of the length of 15x squared plus 3y. I can take the whole thing, the total, and I can divide it by 3 to get the short piece. So when I distribute, 1/3 times 15 is like 15 divided by 3, or 5. I'm not changing the x or the squared, I'm just changing the coefficients. 1/3 times 3y is like 3 divided by 1. I'll write 1y, although you didn't have to write the 1. Okay, now, once I have the medium piece, I know the medium, or once I have the short piece, I know the medium piece is twice as long as that. So if I double what I get here, I have 10x squared plus 2y. If I check my work, I can add those back up to the whole thing again, the red piece. 5x squared plus 10x squared gets 15x squared. 1y plus 2y equals 3y. Okay? So, what we should do is just make a quick little set of rules for what you can do if depending on what they give you. So give me just a second and I'll pop up some rules that you can use. So we just got done talking about the centroid. I just wanted to add this in to the end of the video. This could be a good note card idea. But if it's a centroid problem where you're doing the 2/3 and 1/3 thing, I just wanted to give you a point of reference for these. Sometimes they'll give you the shortest piece first. We know that the short piece is half as long as the medium piece. So what you could do is double that right away to get the medium piece, and then you're going to add those together to get the long piece. So write that part down. Feel free to pause it. If they give you the medium piece first, you can cut that in half to get the short piece. You'll need the short piece to get the long piece. So given the medium piece, you're going to cut it in half to get the short piece, and then do short plus medium to get the whole thing, or the long piece. Okay? Lastly, if they give you the long piece first, you're going to divide that by 3 to get the short piece, take that short piece and times it by 2 to get the medium piece. Okay? So that's in a nutshell how you can do any centroid problem. Feel free to ask questions as you get through the worksheet. All right, thanks for watching.